Alright, so in this video I want to show how to represent our color assets using an enum. I thought it might be good to show the final result at the beginning of the video and then use the rest of the video to show how we got to that point. So to start, this is what the final result will be. It's an enum and a struct. The enum just represents our colors, and then we have a wrapper struct that force unwraps the enum value. As I think about it now, there's a bunch of ways you could use this in practice. You might not need to use this struct. You could really just define your colors. So you could do text primary equals and force unwrap. And since raw color asset is covered by our unit test, we know all of these colors are going to load. Force unwrapping isn't going to cause a crash. So as long as our tests are passing, this is perfectly safe to do. So you could set up your colors as global variables if you wanted to, or you could use some type of wrapper struct that'll force unwrap for you. So for this tutorial, I just use this wrapper struct, and you can see that in action here, where you do color asset that load and then the name of the color. And the app works just as it did before. If you switch between light and dark, it's doing the same exact things. It's just now covered by a single test function that is looping over each case of our enum and making sure it exists. So I'll demonstrate how to do that now. So in the last video, we added some color assets so that our app will support light mode and dark mode and adjust colors automatically for us. So I'll just demonstrate that again. So in dark mode, it uses dark colors, and then light mode, it uses the light colors. And we did that with color assets in here. And I ended the video by saying that one of the problems with using color assets is that the compiler can't check if the color asset actually exists or not. So if we misspell something, then our color will be nil, and then it won't show up when our UI looks broken. Or, even worse, if we were force unwrapping it, then it'll just crash. So that's something we want to avoid. And one way we can prevent this from happening is by using unit tests to verify that these colors actually exist. And I've found the best way for me to do that is by using an enum that represents all our colors and making it case iterable so that we could iterate over all the cases of the enum and make sure that the color actually exists. The alternative would be testing every color individually and writing a new test for every color, or adding a new check in a test for every color we add, and that would be tedious and annoying over time as we're adding and removing colors. So I really like the enum solution because we just need one test. It'll iterate over an array of all the cases and then just check that they all exist. So the way I do that is by creating a enum called raw color asset. So our enum will be raw color asset, which is a string, where the raw value is a string, which will represent the name of the color. So we'll do text primary, for example. So all of our cases are just going to be the colors that we created in here. So I'll add text secondary. And the background colors. Okay, and then there's just a function that I call load that'll return an optional color, just because we can't guarantee that this color exists, so I don't like to force unwrap in the raw color asset enum. So I'll just return the optional color using the raw value of the case. So this will return our optional UI color, which is pretty much what we have already, but we can update it now just for fun. So we'll do raw color asset dot text primary dot load in this example. And it works just like it did before, but we still have the same problem as before, in that if we, force unwrap this, and then if for some reason we deleted text primary and now run it, it'll compile. Our enum has no knowledge that this color doesn't exist, and we're going to get a crash still. So the way that we could fix it, so I'll delete this again. Not really fix it, but a way that we can verify that our colors exist is by creating a unit test that'll check. So I'll create that now. So all we need is one test function. That's just going to loop over the array of all of our enum cases. So we'll do raw color asset dot all cases. I might have to build. Oh, I didn't make a case iterable, that's why. So in order to make it case iterable, we have to conform to case iterable on our enum, which will basically just create an array that represents all of the cases. So now if I build and then do all cases, I have access to the array. And then I just do a for each to get each individual asset. I load the color. And then create an assertion to make sure it exists. And if it doesn't, we'll have a custom message just saying which one failed to load. So now if I run these tests, it should fail because text primary is missing. Oh, I still have this, so let's just run the unit test instead of running the app. And we'll see our test fails. And it'll tell us, failed to load color text primary. So now we know that that color is missing. So we can add it back now, run the test again, and everything should pass now. It does, which is nice. So now we have, even though we don't have the compiler to tell us whether a color exists or not, we have some unit tests that give us a little bit more confidence that there's not a color missing, or we didn't misspell something by mistake. And then what I like to do is, since raw color asset, we know all of these colors exist because our unit test passed. So I like to create a struct called color asset that's basically just a wrapper that will force unwrap the color for us. And I consider this safe because raw color asset is covered by our tests, so we know those are always going to exist. So we could return a force unwrapped color here with some confidence that this isn't going to cause a crash. Just because we have the unit test backing it. So now we can use that for all our colors. So do text primary and then all these other colors as well. And I think it's a lot cleaner because there's no more raw string values, you know, in our actual code. The raw strings are only in the enum. And then if we run our app, then everything works just as it did before. So that's just a simple enum that you could use to represent your color assets. I like to use this because it's so easy to maintain over time. You know, if you add more colors or remove colors, you don't have to update your tests. Everything is going through this all cases array, which is generated by the compiler. So it's not even an array that we could mess up by mistake because the enum itself generates it. So I found it to be really handy. I guess one downside would be that these colors are being created on the fly every time you call this function. If you really wanted to, you could, you know, create a simple dictionary that would cache your colors so that if the color has already been loaded and it's in the dictionary, you just return that instead of creating a new color every time. But just a simple example here to build off of, and I'll probably use this in future videos. I'm planning to do a video on how to do accessible themes. So that'll be, you know, your colors are accessible and we'll work with light and dark mode, high contrast, things like that. Your fonts will resize based on the user's accessibility, font size, and just general theming that you could use. That'll be in the future, and I'll probably link it to this video at some point, but that's it for this one.